Okay, log laws. It's just fun to say. All right, so we've got 3 log laws that we're going to look at. So we've got product, and product says that if you have a log mn, that's the same as having the log of m plus the log of n. Quotient says if you've got a log of m divided by n, that's the same as having the log of m minus the log of n. And power says that if you've got a log of m to the p, that's the same as p times the log of m. Okay, so I'm just going to kind of let that sit, and then we'll take a look at some examples and see how we can use those to make our life work. All right, so let's start with some that just have numbers. So let's say we've got this. Let's say we've got a log base 4 of 2 plus a log base 4 of 32. So the first thing I'm going to notice is that my bases match. So if my bases match, I can use the log laws. This is also using addition, and the only law that uses addition is the product law. So if I have 2 logs that are adding, then I can rewrite them in a simplified form with the product law. So this is going to be the same as having a log base 4 of 2 times 32, which is 64, right? So the log base 4 of 64. From there, we can take this even a step further. So we've condensed it now, but we can take it a step further, and we can ask ourselves, is there just a quick and easy number that we can find that is log base 4 of 64? So like 4 to the what equals 64? Well, 4 times 4 is 16. 16 times 4 is 64. So cubed. So 4 cubed. So this equals 3. All right, let's try another one. We can do that with, let's see, what if we say the log base 2 of 8 to the 27th. Okay, this looks crazy, but I can take this power and put it in the front. So I can say 27 times the log base 2 of 8. Again, I have no variables here, so this is just a number. So what is the log base 2 of 8? 2 times what? Or 2 to the what power equals 8? Well, 3. So 27 times 3, right? Okay, so 27 times 3 is 81. Right? So we use the power law here. We just moved it to the front, and that let us do some kind of more efficient math. Okay, let's try one more like that. What if we've got this? This one's a little more complex. So log base 8 of 6 minus the log base 8 of 3 plus the log base 8 of 2. So again, I have all the same base, so that's good. And then we have to follow order of operations, which means we're going to move from left to right. So I'm going to start with this, and I'm going to say, okay, I'm going to look at these two. They're subtracting, which means I'm going to use quotient. So I'm going to rewrite that as the log base 8 of 6 divided by 3. Well, 6 divided by 3 is 2. Okay? Now I still haven't used this one, so that's still here. So log base 8 of 2. So these are adding, and if I add those together, I get 4. So the log base 8 of 4. All right? So log base 8 of 4. So that's the condensed answer. Now, we can really get crazy here and take this a step further. And if we did that, we would say 8 to the what? 8 to what number gives me 4? Well, I can take a cube root of 8, right? I could say 8 to the 1/3, and that would give me 2. Okay, I'm going rogue here. 2, and I need this to somehow equal 4. Well, 2 squared does equal 4, so what I did here was I really took 8 to the 2/3, right, equals 4, because the cube root of 8 is 2 and 2 squared is 4, so it's really 2/3. But I went off on that one. We can just, for right now, we can just kind of leave this. This is condensed, done. Okay. All right, now, what does this look like when we start throwing x's in? Like, okay, what if we have a log base 2 of 8x to the 4th divided by 5? Okay, so this is like a large division problem. So the first thing we're going to do is we're going to split this by division, right? So I'm going to use the quotient law, and I'm going to break it into a subtraction problem. So I'm going to say the log base 2 of 8x to the 4th minus a log base 2 of 5. So this is equal to, this whole thing is equal to this. I've used the quotient law to break it into its divisor, right? Now from here, I'm going to look even more carefully at this. And there's 2 things multiplying here, which means that I can break that up even further. So I'm going to split this even further into 2 pieces. So log base 2 of 8, and they're multiplying, so we're going to use the product law, which says it's equal to addition, to the log base 2 of x to the 4th. And now we still have our log base 2 of 5 here. All right, now, have I broken down all of my multiplying and dividing? I have. The only thing that's still sitting around is this 4. So I can use power law on that. So I'm going to break that one down even further. So my log base 2 of 8 stays the same. And I'm going to use power law to put this 4 in front. So 4 times the log base 2 of x minus the log base 2 of 5. Done. That's it. That's all you have to do on that. So really your only goal is to just start separating everything down, right? And work like from biggest to smallest. So you've got this big division piece. Take that out. Then break each individual term into its separate pieces. Now if we go the opposite way on that, it's going to look like this. Let's go backwards. So if we have a log base 2 of x plus a log base 2 of y. So this is a nice kind of intro one. So these are adding, so that means we're going to use product law. So we're going to take the 2 pieces and multiply them together. So this can be rewritten as a log base 2 of xy. Right? Okay? Let's do a slightly harder one. How about, so 3 log base 2 of x minus 4, whoops, I can't write, log base 2 of x plus 3 plus log base 2 of y. Okay, so we're going to start with power law, and we're going to move all of these numbers in front to become exponents. So that's going to give me log base 2 of x cubed minus a log base 2 of x plus 3 to the 4th plus a log base 2 of y. Okay, now we've got subtraction, which means we're going to turn these 2 into division. So log base 2 of x cubed over x plus 3 to the 4th, right? And then we still have this log base 2 of y that we haven't dealt with. Okay, and then we're going to now combine these. And so we're going to multiply this times this. So when we multiply that, that y is going to go up in the denominator, which is going to give us log base 2 of x cubed y over x plus 3 to the 4th. And we're done. We're out. That's it. Game over. Okay, I hope that made sense. Good luck.